Alright, we are doing our last unit of geometry. It is G.10, and our topic is similar triangles. Or I should really say congruent triangles. It's not just similar today. We're going to talk about congruency. And what you're going to be able to do after today and tomorrow, you're going to be able to prove, I can prove, two triangles are congruent. That means, remember, congruent means same. So if I give you two triangles, you're going to be able to actually prove that they are congruent, that they are the same triangle. So you need to know the definition of congruent figures. Congruent figures have the same size and shape. So they are the same. Similar have different sizes. Congruent, if I say two shapes are congruent, that means they are the same. Okay? Similar means they're proportional. Congruent means same. Congruent figures have the same size and shape, and corresponding cards have the same measure. And that's what you were applying today with your IXL. You were using congruency and knowing that they have congruent measures to solve for an unknown. All right, looking at these two triangles, how we label triangles. I call this first one triangle ABC. Now, how I just named that triangle is very important. You can name the triangle BCA, CAB, BAC. You can name the triangle lots of different things. But it's important. What you choose to name the triangle is how you need to align it with the following congruent triangle. So when I say ABC, your eyes have to say, okay, she went from A to B to C. That order matters there, okay? Then I have to go the opposite side and say that this is triangle, same thing. I went from, where did I start? No, if I started at A, which is the one that has this one dash, I started at E, then I went to the 3 dash, E to what? Oh, just kidding, I went to the 2 dash, silly me. A, E, D, F. Okay? Order matters. It doesn't matter at first, but once you commit to an order, you need to keep that order for the next one, okay? So it doesn't matter at first, but once you commit, you stay committed. All right? You are loyal to your triangle. What happens here is you have to give congruency statements. Congruency statements, there's 6, because you have 3 line segments to a triangle and you have 3 angles. So your congruent statements, when I say create them, you're going to create 3 segments, 3 angles for a total of 6. So we're going to do that. Here's usually what I do when I first started, because I got really confused. I broke it up into segment and angle congruency statements. And you need to just be able to go through and apply it. So I'd say, okay, me, I'm going to pick a point to start at. I don't care which point you pick, you just have to be consistent. I'm going to start at A. And I'm going to say segment, I just choose to go to B. Segment AB is congruent, the equal sign with the little slash on top, is congruent to segment ED. Yeah? That's congruent statement number 1. I have 2 more line segments to go. Segment, and I don't care how you do it, you just need to be consistent. Let's say I did segment CB. Is congruent to what? FD. Because I started with this, with the 3, the 3rd angle measure, then I need to start with the 3rd angle measure here. So it's congruent to FD. I tried to trick you there, and you caught me. And segment AC is congruent to what? EF. Segment AC is congruent to segment EF. Okay, not too bad. Only halfway done. Now I need to talk about angles, and that's when it gets confusing. Because how I'm going to talk about angles is an upper level way to show it. An angle, think an angle is smushed. Do you see how angles are smushed between two lines or segments? Can you see it? Angle B is smushed, right? It's in between. Angle D here smushed. Angle E is smushed between two line segments. The angle that you're talking about is smushed between two line segments. Can you visualize that? So I use that knowledge when I create an angle measure. Now watch how I do this. I say angle, I make that little angle notation. Angle ABC. Now what is smushed here? What's in the middle? Christian? Well, which is smushed though? B. B is the smushed one. So I'm telling your eyes to go from A to B, and then from B to C. What angle am I talking about? B. Angle ABC is congruent to angle, I got to start at the top, E to what? D to F. E, D, F. There's one angle. How many angles do I have in my triangles? 3. So I have 2 more to go. Okay, so I got this one, I got B and D done. Now I'm going to do angle A, just for fun. It doesn't matter. It does not matter which ones you choose. So A is smushed between 2 line segments. I don't care which ones you choose. You can either go BAC or CAB. Once you commit, though, you commit to the other triangle. So I'm going to say triangle BAC. So I just told your eyes to go from B to A to C. So from the 2 to the 1 to the 3. So I need to do that here. What is this congruent to then? The D to the E to the F. Angle DEF. And there's multiple right answers here, so you didn't have to do it just like me. Last one, angle C and angle F. They should be smushed in the middle. I don't care where you decide to smush. I'm going to choose to be at the top. So I'm going to say ACB, angle ACB is congruent to, where should I start? EFD. Congruent, EFD. All right? All right, that's a lot. So I'm not even going to do the diagram there, but the diagram is just the exact same. It's making you list 6 different correspondence statements. We're going to move to this part. Okay, right here they tell us that triangle ABC is congruent to DEC. They told me how my eyes need to look at these triangles. So I need to go from A to B, and then from B to C. And now notice what I'm doing. I'm just donating each segment a different. So my brain can identify which segments are congruent to each other. So I did my ABC is congruent to DEC. So from D to E, again, I'm going to do circles because that's what I did for the first one. And then E to C, I'm going to do slashes. And then I'm going to do my little squiggly line for my other one. Okay, I'm going to show you my congruency statements. Mine might be different than yours. Remember, it doesn't matter. What matters is once you make that decision, you need to stay committed to the order that you name the segment or angle, okay? So I know that I have 3 segments, and I know that I have 3 angles. So I just like to separate them. You definitely don't have to, okay? Starting with segments, I'm going to say segment BA. So right away I made a commitment. I'm going from my right angle to the angle right under it. So segment BA is congruent. Now I got to start at my right angle on the other one. Segment ED, there's one. Now I'm going to say segment, and I'm just going to follow it along. AC is congruent. If I'm right here, I'm following it along. DC, segment DC. And then I'm just going to switch things up. Segment BC is congruent. Now I went back to the 90 degree. I made a commitment. So now I have to say EC. And you could have flipped that. You could have said CB is congruent to CE. All right, angles. That's where it gets slightly on the difficult side. So I'm going to say angle. I'm going to use C first because it's super easy to get to. ACB, that's this. A to C to B. Angle ACB is congruent to angle DCE. Okay? That's one angle. Another one would be, I want to do my 90 degree last because I like to save the best for last. It's super easy to see. So I just did this one. Now I got to do this bottom one. So I'm going to erase this. And I'm going to say angle BAC. And I chose to start at B because I can visualize where the right angle is. That's the easiest route for me. Is congruent to EDC. Okay? And angle, now I'm talking about my right angle. I like to use angle C, starting there first because it's, again, easy for me to see. CBA is congruent to C, what? C what? CBD. Thank you. I made triangles. 1, 2, 3 segments. 1, 2, 3 angles. I did it.